we're going to fix this TV. We're going to get this little portable Sony TV going. And for 1964, this was a pretty cutting-edge little TV, because most of these, well, pretty much a lot of black and whites had some tubes in them all the way up to 74, 75. They were on their way out, but this is a little beauty. And what I've been told is that it works, except it has no video. So it has a raster, just has no video. Let's take a look at this little Sony and see what it does. We will. The only reason I'm doing this is because the owner of it plugged it in already and fired it up. Well, that's interesting. That's the vertical. Well, you got a noise machine here with the vertical and horizontal hold controls. I have to think about that one for a minute. Bad capacitors, maybe? It's always bad capacitors. These are the horizontal output transistors. It actually has two paralleled. And these are really early, 1964 horizontal output transistors. I don't know how many sets on the market had transistor solid state horizontal output, but not many. So this is filled with those crappy Elna capacitors. Look at that. There's probably not many of these around. This is a really early example of a solid state TV. Look at those big 2SA70. Wow. A lot of early FM transistor radios use those. See the big germanium transistors? Wow. This is a bit of a rare set, especially to be in this good a condition. It looks a lot younger. This has that corrosive, that glue, that brown glue that turns corrosive. Look at how the glue has corroded these transistors. Look at that. See how they had a dot of glue there between those two transistors? Look at how it's corroded the metal. Same thing here. Look at it. It's caused the whole case of the transistor to corrode. These look okay because they... And what is in that glue? Look at this one. Same thing. Transistors all corroded. They put that glue on yolks and it eats the coils. It eats the copper up in the yoke. I don't see it on here. Obviously the yoke is not open because we got full deflection. Anywhere you see that brown glue, beware. I wonder what's in that stuff. Oh, look, you can see that capacitor's puking right out the bottom right there. Look at that. Are these big aluminum electrolytics? Got several. Man, imagine being a tech in the late 1960s and having this thing come in for repair. You'd be like, nope, don't know anything about that. Don't work on that. Okay, first capacitor, 10 ohms. This one's a little bit better at 5 ohms. This one is actually tolerable at 2.5 ohms. Well, some of these are just dead and other ones are okay. It should totally be recapped. Every single one of these capacitors needs to be replaced. That's just standard on these old Sonys like this. But since this is not mine and this is probably going to be a shelf queen, I can't believe the deflection works with these capacitors. I can't believe it's got full vertical deflection. So far I've changed 4 caps. All of these had puked out the bottom pretty much. All of these were totally open and bad. All the rest of these read in the yellow or green on here. Yellow or green. So I'm just doing the minimum here just to get this to work. This was one of them right here. So let's put it back in, see how it works, and then do the deflection board. It might be a little bit quieter, probably because of that one right there that was open. That's probably a filter. All right, the next thing to do here is take pictures of where all these wires connect, and then get the deflection board out and check the capacitors. It's very possible or highly probable that one of these transistors is bad. I've seen these 2SA70s go open or bad a lot in transistor radios. 60-year-old transistors are kind of hit and miss. So yeah, pictures and then removal. Yeah, there's a lot of stuff connected here. Well, here's a thing. Most all of these are testing good. This one's a little bit weak for a 22, but all the rest of them are up in the green, below an ohm ESR. So no wonder why the deflection's working pretty good. I think I'm going to have to figure out how to get to the big electrolytics. Well, this is certainly different. 4 screws around the edge. How about that? Is that awesomeness or what? And now I can get right to the back of those electrolytics. That is cool. Wish all TVs were like that. Imagine if that stupid Philco 17er was like that. Look at this guy here. So yeah, I can check these. I didn't see this one. This thing does have 3 tubes in it. A high voltage tripler circuit inside the flyback cage, which is right there. Ooh, selenium rectifier. Wow, there's a lot. And you could get in here and clean the controls. Wow, is this thing serviceable. This is a whole new level of like awesomeness. Look at, there's another one hidden right there. There's another electrolytic right there. There's just layer upon layer of electrolytics here. So let me check these. All of them check good, except this one here. Another 50 at 12 volts, like the one on the back. All of these check below 1/10 of an ohm. All very good. They're either 100% or they're 100% dead. There's like no in between for these power supply filters. I changed that 22 just to leave a mark that I had been there, so I changed 2 more, and the 22 wasn't bad. The one on the back of the power supply was bad. So let's see if there's any difference here. Ooh, a lot less noise. Ooh. We might be about there. No video. Nothing in the video. There's, ooh, it's got the dot. It's got, there's a couple capacitors. I might change these two. These are in the video, I believe. Well, I pulled this board back out and double checked all these capacitors. I did end up changing that one. The 210s were pretty dead. That one was dead. Really wasn't bad. The set is acting like it's got a dead IF stage or a dead tuner. Because it's a beautiful raster, but there's just... seemed like there was activity from this last time, but now there's nothing. And all the noise seems to have something to... So yeah, it really seems like a dead IF stage or something, and it's just picking up a bunch of trash. Now if we look at this, it's using the old 25 megahertz IF. So the VG91 will not work with this. I have to use the old 1076 or 1077. This is the IF frequency from the early 40s and 50s sets, plural. 22 megahertz. And yeah, it uses, let's see, 1, 2, 3, 4. How many of these 2SA70 does it use? I mean, they're a damn good IF transistor when they work, but they do fail a lot, and that's these big things here. So that would probably be IF 1, 2, 3, and 4, or something like that. let's see. Let's look through this. I pulled this out and I scanned this in preparation for this video. It's a big thing for me to have service data. You know, spend the money, spend the time to get your service data. Why do you want to waste your time not having service data if you can? Wow, the AGC keying. Okay, there's the fourth video IF, third video IF, second video IF, and first video IF. So the audio transistors are the ones that we saw getting warm. So first video IF, AGC regulator, whatever that is. Second video IF, the corroded one here is second, third, fourth. What is this up here? This is the AGC keying. I wonder what this is for. Well, also, well, this is the AGC pot, but it has not been moved. So we're going to have to get it in the house, and we'll try feeding it with the VG91, but my hopes are not real high. On channel 4, this thing does seem to be picking something up, but and this sound thing, right here is the sound. That's the sound. Is the thing oscillating or something? I mean, there's no kind of shielding on this. Put it on the VG91. I got the VG91 here on a full 5 volts on channel 4 and just nothing. If I turn the generator off, it sounds like there's something getting through. That's on channel 3. And turning the fine tuning does make a difference. What we should do is take the video out of the VG91 and drive it straight into the video amp on this. So the signal comes from the tuner into here. It's amplified through the IF stage. Right here's the detector. Right here, point A. That's our test point. We want to feed video into there. C12 is this capacitor right here. I'm clipped on. We're going to start with the 1076. I think this works. I did a video on this. But this will do the 25 megahertz IF. So we're going to start with the video, and this will do video out and work our way back. If you're not familiar with this, here. Uses a flying spot scanner tube. Well, let me get this set up, and I think I even have a slide here for a crosshatch. Yeah. 1077 the year after this is a lot better. And there's a ton of these for sale. Probably don't want that touching the rectifier tube there, do I? Alright, so there we are going directly into the video. So, picture works or contrast, brightness works, vertical and horizontal hold are working. So we know the problem now is in the IF or the tuner. I'm going right into the tuner, where the tuner comes into the IF. Am I going to have to feed into the base of every one of these? There's no video. Well, that makes it nice to service and work on. And the SAMs will kind of show us what base, emitter, and collector is. It's not the easiest thing to use. Well, if I go into here, which is the second IF, it's certainly louder, but still no video at all. This is a weird one. Maybe what I should do is I should start checking DC voltages. Maybe we have a cap that's shorted. You know, the ESR meter will tell you if the ESR is low, but a capacitor that's shorted would check good with the ESR meter. So maybe I ought to start checking DC voltages here. It's possible there's a shorted cap that's pulling down the voltage to the IF. It's interesting, this blue paint. I thought that was factory, but I'm starting to think not. I'm starting to think that this is a problem that someone else couldn't figure out, because the blue paint is only on the 3IF transistors and the video transistor where the problem is. Anyway, this is the third IF transistor. This is base, emitter, and collector marked by the blue paint, and the same thing down here. So emitter should be 7.8, base 7.6, and collector 0. Okay, so this is the base. It should be 7.6. This is the emitter. It should be 7.8. And this is the collector, which should be 0. Someone else has been here before, and they didn't figure it out, and they gave up on it and sold it. And now I'm here trying to figure it out. Oh boy. This thing has 4 IF stages. So this is the third. We're working our way back. This is the base. It should be 8.6. This is the emitter. It should be 8.9. This is the collector. It should be 0. Someone else gave up on this. I went through and checked the rest of them, and the voltages are all right on. And I would think if we had an open or shorted transistor, it would show. It's not an end-all test, but it's a pretty solid test. Now, more I think about this, somebody else gave up on this. And one thing I've learned is don't underestimate the skills or the qualifications or the ability of a tech that worked on it previously. Obviously, if they went through and marked all of these with blue dye, they were competent enough to do what I've done so far. So they obviously gave up on it. Now, I'm not going to give up on it. Now, the reason I marked the bases is because I want to go with this and inject directly into those IF. I would think if it would be a problem with the AGC, the voltages would show that it's cut off, and it's not cut off. The voltages are too close for that. Maybe I'm missing something because it is a keyed AGC, but I'm going to try and inject into the yellow. And doing this should be just like diagnosing a radio. So if you listen, it seems like it's working. This is the last IF, so 4, 3, 2, 1. Listen. And no matter where I inject, I never get any video. So it's just strange if I inject right here into this base, I get no video. But if I inject video into point A, I get good video. So is the 1076 not working? Is this video detector diode bad? I mean, if I inject right there, I would think I would get something in the picture. A little faint something. If I inject the RF into that test point after the detector diode, I get video. So where's the other side of that? Is that damn detector diode bad? So this thing is in a box. That's what that dotted line is. So we want flag 15 and flag 16. So we come over here and we look at flag 15 is right there, and flag 16 is right there where I'm injecting it into. So if we go, this is 16, I believe. This is the detector diode out. This is the other side of the detector. So it's like there's nothing getting through that detector diode. Measure that with an ohm meter. Measuring the detector diode. Have I seen these go bad? Absolutely. And bad detector diodes will drive anybody crazy. It's measuring it one direction, nothing. It's measuring it the other direction. That's touching the leads together. Well, if I'm measuring the right place, no, there's no capacitor in there, right? No, there's a 4 ohm coil. I'm measuring from 15 to 16. I wonder where that no connection is here. Okay, I believe this is the no connection right here. Let me do this. Let me go to ohms. Ohms. Should be 4 ohms. That's right on. The freaking diode is bad. Let me check that one more time. The detector diode. Should be from here to here. I mean, why did it beep for a second, but then it didn't read anything? I don't get that. It beeps for a second. Learn your test equipment, you idiot. Maybe I should get a diode and test it. Okay, here's a germanium detector diode in a GE radio. Okay, it's open that direction, and it's measuring 300 millivolts that direction. So why... Nothing. I'm back on the TV. This thing's got a bad detector diode in it. It's got a bad detector diode in it. The detector diode is in that box right there. You can see right there where the box is. So it's right here. There's the no connection. There's the input. And there's the detected output. I don't know if that's repairable. It's got a coil and 2 or 3 capacitors and a diode in it. I wonder if I could just tack a diode on the bottom. Just take the damn diode out of that GE radio. Take this diode right here out of this GE radio and just tack it right on the bottom. So that would affect the sound as well, because the sound is taken off right here. These 2 lines here go up to the sound, and then the video is taken off the emitter here. So that video detector diode would in fact affect the sound and the picture. I think I installed it right, and I think this is probably a 1N60. This is out of a GE AM/FM radio, 10.7 megahertz. I don't know how this is going to work with 26 megahertz. I have some VHF Schottky detector diodes. I might put one of those in there if this works. What I'll do is I'll cut this trace so that it's no longer connected going into the little box. Let's try it. Okay, here we go. Ooh, no more squealing, no more motorboating, no more... Wow, do we have static? We do. No more vertical noise, no more horizontal squealing. It's no longer a noise toy. But look. I see static now. Watch this. Fixed it. Bad detector diode. I just set that there. Now let me play with the frequency control. There we go. Wow, just a bad detector diode. That's all it was, and someone else gave up on it. So there it is on the VG91 on channel 4. It's working. It's ready. We're ready to watch some TV. What a weird symptom that created. all that weird buzzing and moving your hand next to it and it going away. I guess because the base of that transistor was just floating open. The diode was just open. I think I'm just going to leave it. I'm just going to leave that diode in there just like that. It seems to be working just fine. I got to put this board back in. I think it relies on the grounding or something. Look at that. That's when you know you got it right. Imagine the disappointment if I got this and just did a full recap on it, including all those electrolytics, and not been able to figure the bad detector diode out and actually Let's watch some TV.
Necessity and waiting any longer and wanted to do this now. President Biden is headed to Africa for what is most likely going to be his last trip abroad as president. And you're looking there at where he was over the weekend. And that was with his family on Nantucket. You see Hunter Biden, his wife, and his son, Joe Biden's grandson, there with him, walking on the streets of Nantucket. And
CRT is very strong in this. So bright it's causing the camera to blank. Look at how sharp that is.
it's about $200. If you count shipping and handling, it's over $200 in savings.
What's all this crap with the monkeys?
It is struck in 1 troy ounce size and is guaranteed to be 99.9% silver.
It is?
The first American silver eagle was struck on October 29th, 1986 at the San Francisco Mint.
On July 9th, 1985, President Ronald Reagan signed the Liberty Coin Act.
Trying to find stuff that's not on the copyright tip. Anyway, I think we can wrap this up. Ooh, Christmas lighting made easy. Ooh, is this the star shower?
That's so fun. I love that.
Okay, wait. There's more. The same button. Hit it again. Look back there.
Blinking. I love that sparkle.
Wow.
You never be able to get that with any string light.
And it's all as easy as placing it in the ground, plug it in, and point it to the house. Instantly, you get thousands of lasers, and each one is pinpoint, vibrant, sharp, and crisp.
It's so much easier.
Listen to the music in the background. It sounds like some 60s
All the string lights, right? You had to deal with the frustration of untangling all of them, and then get on a ladder. That's what I had to do. That wasn't very safe.
Scary.
And then you're out in the cold or the rain, and if one bulb goes out, you gotta check them all.
And the worst part is, even after you spend all that time and all that effort, you're going to get stuck with a house that's barely lit, and there's not going to be any motion. There's no variations whatsoever.
Forget all of that. Yeah, now you get your Star Shower Ultra 9, you place it in the ground, you plug it.
and this is a solid fix.